Okay, well, welcome back to class. Last week we covered the beginning of the flood, as it was recorded in Genesis 7:11, when the fountains of the great deep burst forth, and we found that it was on a specific day that this happened, recorded in history. It's this 17th day of the second month, and this marks a significant event in history, probably one of the most significant events in history. And kind of should be remembered kind of like we remember September 11th or December 7th or July 4th. So we are going to start going through the phases of the Great Flood today, kind of what happens through the flood. We'll do a Bible timeline where we'll talk about the flood, not lasting 40 days and 40 nights like some people may automatically answer, but the flood actually lasts 371 days total. And last week we talked also about the incredible amount of energy that would have been trapped in the subterranean waters deep below the Earth's crust, especially given the 1650 some odd years there was between the end of the creation week and when the flood starts, and that there would have been a huge amount of energy in this waters, primarily from the moon's gravitational influence on the Earth, something Walt Brown calls tidal pumping. There was chemical energy in the subterranean waters. When it reached this kind of pressure and heat, there could have been burning. And if there's any kind of fuels present, there would have been burning. And some of the chemicals that would have been released and dissolved in these waters would have been combustible. And there's also what's called potential energy. So it's this tremendous amount of weight from this 60-mile high crust pushing down on the water. So when a small crack opens, it's like a squirt gun, basically, of unbelievable size. You know, water would have just shot out of this. And also this supercritical water, when there's a release of pressure, the temperature drops suddenly, there's been also a tremendous release of energy from this. So Walt Brown has estimated that it would be roughly the equivalent of about 5,000 trillion hydrogen bombs or atomic bombs released in this energy. So we talked about the energy sources. We started to talk a little bit about the flood phases that Walt Brown has put together in his Hydroplate Theory. And so that's what we're going to do today. We're going to get into this in some depth, a little bit of depth. Really today is more of an overview. I want to give you like an overview of the entire flood. I don't know if we'll get through all of it today or not, but we'll try. I've got a chart here. I'm going to show you the overview of the Hydroplate Theory, and then a handout, a printed handout here, which kind of describes these different events. And then we're going to go back as class progresses and go into more depth into some of these, if not hopefully all of these, different aspects of the flood, when they occur, and just what they meant, you know, just what it was about. So, so we talked last week about imagining that the Earth is a big crime scene. You know, basically it is. What would have happened during the flood would have created a number of unusual anomalies in the Earth today, things that are not explained by traditional evolutionary theory. You know, different, we'll go through some of that today too. Mysterious things that don't seem to have an explanation under this old Earth evolutionary processes theory that is so pushed on us today. So I imagine like we were a big crime scene, you know, an accident scene. We're going to look at, like a forensic scientist, we're going to look at this accident scene and try to figure out, well, how did it get this way? That's what we're going to do. So we're going to look at cause and effect relationships going back in time to try to find what would have happened had this fountains of the great deep ruptured, given that we had already established, I think, that there would have been tremendous amounts of trapped subterranean water well below the Earth's crust, and that was put there and detailed and chronicled in Genesis chapter 1, verses 6 through 8, where the waters are divided above and below a crust, a raqia. And numerous other passages that we covered in previous classes refer back to that too. So I think I'm very confident in saying that this is how the Earth was arranged initially. So again, put on your trench coats and your funny looking caps and let's get to work on this. So our crime scene is the current Earth. Here's a map of the Earth. We started looking at this last week. And we can see that there's some strange features on the Earth today that just can't seemingly be explained. And then again, as we go through this phases of the flood, we're going to get into this. a bit deeper. But we can also see that there was an apparent place where this crack actually started or began by looking at what are called the mid-oceanic ridges. And we're going to talk about those a bit today. You see this huge scar. And imagine how big this is. I mean, here's Africa. You can see on my pointer there. Here's South America, North America, and Europe. And look how big this is. Look how huge that mountain chain is. This is absolutely enormous. And we'll find out two aspects or characteristics of this mountain chain are not like any other mountain chain on Earth. The way it was formed, it was completely different. We'll get into looking at how this, the specific characteristics of this mountain chain and what could have possibly caused it to form. And we'll find out as we get into this deeper too that it's not something called seafloor spreading. It can't be. Seafloor spreading is something promoted by traditional secular geologists today as explaining this, that basically there's magma or molten rock that comes up at the middle of this oceanic trench and somehow spreads plates apart, that these plates then go and push against the continents and then subduct under the continents. And I'll show you scientific reasons why that can't be true. It just can't be right. So that's called plate tectonics. We'll get into that a little bit deeper. But anyway, as we get into this, we'll find that this oceanic ridges, as they form, will cause these plates, or called the hydroplates by Dr. Brown, will start spreading apart and moving away from the mid-oceanic ridge. And this will cause dramatic changes to the Earth. And again, we're going to go into this a little bit deeper. So,
Steve, question.
Yeah.
You say that they think the crack started with a red surface. And did it come by Greenland on its way south?
Yeah, it's kind of interesting. I'll show you an animation of this in just a second here. So watch this. But the strange place where we're going to focus on a little bit later on too is this unusual place right here in the Indian Ocean, where this mid-oceanic ridge actually bisects this one, and they come together. So if seafloor spreading is true, and the rising of this is kind of like a conveyor belt, according to seafloor spreading, according to plate tectonics, what's happening here? How can something spread simultaneously in two different directions? There should be a big pileup of material here where these two are coming together if both of these are rising and spreading. We'll come back to that too. There's also another very unusual anomaly on the ocean floor, and it's called the 90 East Ridge. It's this ridge right here. And we'll come back to that too as to what would cause that. This is another mysterious feature. It's a straight line on the ocean floor, and it points right toward, he'll give you a little hint here, points right toward the Himalayan mountains. So we'll talk about that. I don't want to get too far into that. The Himalayan mountains. The Himalayas are right here. So this is where the Himalayan mountains are, one of the biggest mountain chains in the world. So as we look at this, we can now do an animation thinking that if this crack intersects this crack, this one must have ran into this one continued on first, and then this one came around and intersected it. So if we find this point right here, we'd find a point of intersection. If we run it backwards in time, we can come up with an approximate location of where this crack would have started. So here's the animation in forward, and you'll see exactly what we're talking about here. So this part of the mid-oceanic ridge passes by, and then this one has to stop when it runs into it. So this is, again, there's some very unusual features on the floor of the ocean that we'll go and explain this. Let's see. I've got a couple handouts here for you. There you go.
I'm glad you outlined that black. Kind of one of my other questions. Before you can really see it, but that's what I'm.
You can really see it when you do that, and so.
Western part of the United States, if that's where that.
Now, another really interesting place too is where you'll see it come across the western part of the United States. It actually goes a little underneath California in the western part of the United States. And we'll also talk about the Rocky Mountain chain here.
Where I was actually wondering if that's where it went.
Yeah, so if this plate is sliding and runs into huge amounts of resistance and buckles and crushes, you can see how that would have raised up mountains as it ran into the mid-oceanic ridge, as it slid over the top of that oceanic ridge on the western part of the United States. And you'll see too, the southern, down here, there's also the Andes Mountains that run on the western side of South America. Well, they're not nearly as big or as thick, right? They didn't run into this mid-oceanic ridge like they did up here. So that explains why this mountain chain is so much thicker. That's something we'll look into when we get into what's called the compression event, which is after, during the flood phase. So here's the chart that I have given you today. We're going to spend probably the whole day the whole class looking at this chart. And so I want to give you an overview of what happens start to finish on the flood, the phases of the flood, and see what happens during each one of these phases. And as you do this, to me, it all makes perfect sense to me anyway. When you see this thing lay out like this, and so many of these unusual features of the Earth and even the universe are explained by this. So the first phase of the hydroplate theory basically is called the rupture phase. Rupture phase. And that begins, of course, on day 1 or day 0, basically, of the flood. And that's recorded as happening in Genesis 7:11, when the fountains of the great deep burst forth. And so this rupture begins with a deep crack in the Earth's surface. And because of the stresses and tension cracks that are concentrated at each end of the crack, we can see that this crack would have rapidly grown at the speed of just under 3 miles a second, which is the speed of sound in granite. So this crack would have raced around the Earth in a great circle path, as we just saw in the previous slide, and the 60-mile thick crust would have opened up, kind of like a slightly stretched cloth would open up, or tear. So huge amount of pressure here. So the pressures in these subterranean chambers directly beneath the rupture suddenly drops. It suddenly drops from over 3,200 pounds per square inch to basically 0, 1, basically standard atmospheric pressure. And this causes this supercritical water to violently explode out of this crack. And so it wraps around the Earth, like we saw, kind of like the seam of a baseball does. Think of a baseball and how the seam of a baseball wraps around a baseball. It's kind of similar, kind of a good way to remember it there. So the fountains of the great deep burst forth, just as we talked about. And Scripture tells us that this burst forth, this Hebrew word baka, means basically to rip apart or tear apart. This is not a gentle thing. This is an explosion, basically. This is a violent process that happens here. So in the process now, huge amounts of water now come to the surface of the Earth. So we had all this, we had half the water that created during the creation week was above the crust, half below the crust. Now this water, or great amounts of this water trapped beneath the crust, now has a way to escape to the surface of the planet, of the Earth. And we see now that there's so much that comes to the surface that the entire surface of the Earth is covered, just as is recorded in Genesis 7, 19, and 20, where it says that the highest mountains were covered by 15 cubits, or about over 20 feet of water. So during this process, massive amounts, just tremendous amounts of dissolved minerals would have been swept out from underneath the plates and brought up to the surface. So the reason for this is that the supercritical water has great dissolving capabilities. It basically, you know how water, you can dissolve things in just regular water. As you heat up water, it tends to dissolve things even more. So as you get into looking at this supercritical water in the heat, over 705 degrees under unbelievably high pressures, would have dissolved great deals of amounts of sediment from the chamber floor below, which is the mantle, and between that and the bottom of the crust above. So the crust above was primarily granite. So we would have seen the dissolving of a lot of sediments and a lot of materials that now, when this collapses, are swept up through the crack in the surface, the openings up now of these plates, and brought to the surface. So here we got the entire planet, the planet Earth, is all covered with water now, and tremendous amounts of sediments are also brought up mixed in this water. So this will explain the forming of the Earth's strata layers. So we'll see that a little bit later. We'll talk about that. But realize for now that the Earth is covered about 70+% of the Earth's surface now that's not underwater is covered with sedimentary layers. There are layers that are miles thick in some cases of strata layers of very pure, different materials layered on top of one another. And you can see this worldwide. I mean, this is all over the place. Probably the most striking example most people would think of right away is the Grand Canyon. So look at the Grand Canyon, you'll see layer after layer after layer of very pure material in different layers. And the process of sorting this into these layers is a process called liquefaction. And liquefaction is kind of a well-known process. Actually, it's used in industry to separate different elements from each other by getting them in water, basically, shaking it up a bit. And what you'll find is that the heavier particles will sink to the bottom, the lighter particles will start to rise a bit, and very quickly you'll see these layers start to form. And Dr. Brown did an experiment where he took 2 big 5-gallon water jugs and put them on a teeter-totter where you've got one water jug on the other, one side, one on the other, and there's a pipe connecting the two, and put a bunch of dirt in one and put water in it, and he started tipping it back and forth. What would happen is as it tips back and forth, it would force water into the jug, the 5-gallon water container that had dirt in it. So that would lift particles as they got wet, and by rocking it back and forth, it didn't take very long, and you'd start to see layers develop. You'll start to see layers, very distinct layers, develop rather quickly. And this happened actually when Mount St. Helens erupted too. Mount St. Helens was very similar when that volcano erupted a number of years ago. So we see this now on a global scale. So we've got the entire surface of the Earth covered with water. There's tremendous amount of movement in this crust. We'll talk about that, where the crust will be flexible somewhat. I mean, it's 60 miles thick, but think of it on the scale of, you know, how huge this would have been. There would have been, you can imagine, there would have been flex in this crust. And so flex in this crust would have caused movement, which would have caused the waters to be basically waves in the water that would allow this to happen. So we'll see that this happens rather quickly, is probably within a matter of a few months, not millions of years, the way evolution tells you that it does. Okay? Evolution will tell you, hey, these layers were laid down one after another, millions of years between them. Doesn't make any sense. There's numerous scientific reasons why that's not possible. One would be, well, okay, you've got a layer of very pure material over tens of thousands of square miles, covering tens of thousands of square miles. And then you got another layer of equally pure but different material that covers tens of thousands of square miles right on top of it. Where did that material that was on top of the lower layer, where'd that come from? Okay, where did it even come from? And then secondly, how could it spread out so evenly over the layer that's already there? Why, if there's millions of years between these layers, why wasn't there any erosion? Why weren't rivers, or why wasn't there some erosion between the layers? But no, these layers are distinct and there's no erosion between the layers. And then why do you find what are called polystrate fossils? You find fossils that go up and down through multiple layers. Most of these polystrate fossils are trees. And we see these trees worldwide. Again, we'll show you some pictures of these as we get deeper into the class. But this is an amazing thing, is that you'll find a tree trunk vertical through 2, 3, 4, 5 layers of strata in some cases. And the tree doesn't show any signs of decay above the first layer. It's all the same, indicating that if that tree was partially buried and then stood there for millions of years, what would have happened to the tree above that? Okay, it would have decayed and rotted, right? A long time, it wouldn't last that long. But we see trees that are in perfect condition. And we see trees in the strata layers, in these polystrate fossils, where they don't have any root balls. The roots are gone. So you see the tree vertical, and you'll see that it looks like the tree's been ripped out of the ground. I mean, it's just like, imagine pulling weeds out in your front yard. I've done this many times. You yank a weed out real fast. In some cases, you yank out the weed, but the roots are left, right? Okay, and then the weed grows back, right? Okay, so you got to dig that thing out, right? You got to get it out. So imagine now that there's a tremendous amount of water rushing over the surface of the earth and scooping up everything in its way, including trees, and ripping up tremendous amounts of vegetation in the process. And some of these trees that are found in these strata layers and these polystrate fossils are actually upside down. They're actually the root balls at the top. The tree is below. How does that happen? You ever seen a tree grow upside down? I've yet to see one. I've yet to see a tree that grows upside down. So the only thing that explains this is that there was a huge violent event that tumbled all this up, kind of like it was been a big blender. And all these trees and vegetation and animals and various things get caught up in this, just like it's a big blender. And this is what will cause or form our fossil layers.
Oh, but I'm really curious about that.
We'll get to that in a second.
Okay.
We're still in the early part of this. We're kind of still in that first picture there. Like I said, we won't get through all this today. I can see that right now. But I want to give you an overview of all this, and then we'll go back and spend more time on these later in the class as well. So that first picture you see on the upper left there that is up there, up in this area, is kind of realize where we're talking about right now. And all these things are sort of interrelated too, so a lot of things do kind of all come together. So as this globe circling rupture occurs, basically the mid-oceanic ridges, it follows basically that pathway. We'll talk about that when we get to the next phases in the flood. But we'll now see that huge amounts of water are jettisoned out into the Earth's atmosphere and fall down as torrential rain. I mean, absolutely torrential rain. Imagine huge amounts of water that explode up into the Earth's atmosphere and then come back down. This explains the 40 days and 40 nights of torrential rain. Okay, this rain was not from clouds evaporating water out of clouds. This was a completely different rain. The rain here in Scripture is described as gesham. It's the Hebrew word geshem rain. And it is a totally different rain. It is a violent, it's like think of a torrential downpour like you've never experienced. I mean, that's the aspects of what you want to get out of that. So this is where the 40 days and 40 nights of Geshem rain begins. It begins when the fountains of the great deep burst forth. So other jetting water rises high above the Earth into the atmosphere, and as you go higher, temperatures get colder. What ends up happening is that it freezes. So once this water freezes, it falls on various regions of the Earth, and as a extremely cold, muddy hail. So think of water going up into the atmosphere. We all know about snow and hail. This would have frozen rather quickly and come back down rather quickly as very muddy hail. And so within hours, this hail would have buried or did bury and suffocate many animals, including what are called mammoths and rhinoceroses. And they were flash frozen basically in locations that they didn't normally live, okay, as far as the temperate part or the climate of the Earth. So there are 58 separate, well-documented discoveries of remains of these animals that have been found and documented in Alaska and in the northern parts of Siberia. So this is up in the very northern part today, which is very cold. It's very cold. These are not animals that live in that kind of environment typically. So these animals are flash frozen, some of them with their stomach contents still intact. And when they have dug up some of these animals and they find undigested food in their stomachs. So this happened extremely rapidly. They were basically flash frozen. So there's no real explanation for this under any standard evolutionary or scientific explanation, but the hydroplate theory gives us now a solid, scientifically explained, scientifically sound method by which this could have occurred. So this is basically the frozen mammoths. So we're now down to here, the frozen mammoths here. This now also has jetted material up into the Earth's atmosphere with such force that it actually goes out beyond the Earth's atmosphere. It's actually jettisoned out into outer space, past Earth's gravity, past the Earth's atmosphere. And what ends up happening is that this debris is headed out and past the Earth, basically all in the same direction. And we'll show you processes where that debris and water mixture could then start coalescing to form comets and asteroids, which basically are clumps of rock. So the standard evolutionary idea behind these clumps is that somehow they came together at different directions and globbed together. Well, that's not possible either, because if they came together in different directions, they'd actually blow each other apart. Okay? They wouldn't coalesce like this. But we know everything basically has a gravitational force. I mean, every object has a gravitational force associated with it. The Earth, the moon, the sun, but everything does. I mean, even my mouse here, there's a gravitational force associated with it. And as this material is all headed in the same direction, it'll start actually to come together because it's headed the same direction at the same speed, and it starts to form asteroids. And we'll show you asteroids, basically just clumps of rock. And we'll show you also how comets could have formed, not directly from the Earth, but as a process of this. And then the gravitational forces of the sun then will capture some of these comets and cause them to orbit the sun, which we will look at as well. So another aspect of this too is a lot of this ejected material out from the Earth is ejected out into outer space again and strikes the moon. Okay, so this causes intense cratering on the moon, both on the face of the moon, which looks completely different than the far side of the moon. So the front side of the moon looks like it's had serious impacts to it. I mean, it has been like shot with a shotgun. I mean, it has had some very serious impacts to the front side of the moon. But the far side of the moon, if you remember, the moon always orbits the Earth with the same face facing the Earth. The far side of the moon on the other side always faces away from the Earth. We never see it. The dark side. It's not really dark. It depends on where the sun is. That's you going back to your Pink Floyd days. I know that. I get it. But the far side of the moon, sometimes it's lit up depending on where the sun is. But the far side of the moon is completely different. It has a lot of small craters on it. The side of the moon that faces us has what are called seas, or what look like seas. They're not, or what are called maria. And if you look at temperature measurements of the moon, you'll see various aspects of the moon that are hotter than others. And it has been hit very hard by something. And hydroplate theory proposes that this is where that came from, is this material that hits the moon was ejected from the Earth and causes these craters. And the thought of having over millions of years so many different impacts to the moon doesn't make sense, in that from this side of the, when the sun is up, or the moon is up above us, it's been hit as it looks like something came directly from the Earth. So if something was coming in from the Earth, that direction, it would have hit the Earth first, because the Earth's gravitational pull is stronger than the moon's is. So it explains how this could have happened. Also, backing up just a second to comets and asteroids, one interesting aspect of asteroids is they're now finding organic material on asteroids. So they're finding remnants of basically living things on asteroids that have been collected. They've collected samples. So evolutionists, of course, would say, well, okay, that's what seeded Earth with life, right? It brought Earth from outer space here on asteroids and comets. Well, a better answer for that is that it actually came from the Earth. Okay? There would have been huge amounts of vegetation and organic material on the surface of the earth when the fountains of the Great Deep burst forth. A lot of that would have got swept up, and that explains where that comes from. So I didn't put it on the sheet here, and I guess I forgot to put it on here, but this also is where the Earth's radioactivity starts. So at the beginning of the rupture phase, now we see huge amounts of fluctuation or bending in this crust, the raqia, and bending of this crust would have created huge electrical voltages in the crust. And I'll save this for a deeper, further class because it gets kind of technical. But this would have caused great amounts of change to certain elements that would have caused them to lose electrons or gain electrons and become radioactive. So remember we talked back at the end of creation week, everything was declared as very good. The Earth, therefore, you wouldn't think would have had any radioactivity involved with it, any radioactive materials, because we know radioactivity can be very dangerous. It will give you all kinds of problems. So thinking that the Earth had radioactive material on it when the Earth was initially created doesn't seem consistent with what God would have done, right? So here gives us an answer that's scientifically sound again as to where radioactivity would have started. It would have been produced during the rupture phase, and it also would continue on through the flood phase, as there's a lot of fluctuation in this crust that continues on for probably many months. So the rupture phase basically occurs on one day. See that recorded in the scripture, which says all the fountains of the great deep burst forth on one day. We can see that this crack then could encircle the earth because of the speed of the crack in roughly a few hours. It wouldn't have taken that long to go around the earth. So the rupture phase, very quick, it's one day. The flood phase, which is the next phase we're going to talk about, starts on day 0, basically the same day the rupture phase is on, but then continues on for many months. So during the flood phase, we see numerous things that occur here as well. So as we see this amount of water come out from underneath the plates, we can look down here on our chart, we can see that there have been a large amount of water coming out from under the plates, would have started to cause a large amount of erosion on the side of the plates as all this water comes out. And it would have formed what are called continental slopes. If you look at a map of the Earth's ocean that we saw before, and I'll show you this again later on, all over the whole Earth, basically the continental shelves are at the edges of all the continents where they go out and go into the water a bit, and all of a sudden there's a huge drop and go very deep. This is worldwide, all over the Earth, except for 1 or 2 little areas, but pretty much all the continents do this. So what explains that? So we'll get into that as well, but these continental shelves would be basically where all this material erodes out and spreads out, but leaves vertical edges to these continents as all this comes out from that. So again, we think about these continents were at one time, Walt Brown estimates they were about 60 miles thick. Now they would have eroded from the erosion underneath to be thinner than that because of all the erosion from the underneath side of the plate because of the supercritical water that happens, but we'll come back to that too. So, so after the flood, not too long after the flood, the sea levels, as we look at the floor of the ocean, if you imagine that the sea levels were lowered by not a whole lot, maybe a few hundred feet, some of the continents would actually be connected. And what this would do is would allow migration of animals and man all over the world after the flood ends. So this now gives us a way for the earth to be repopulated. So God had a covenant with Noah following the flood. It's recorded in Genesis 9:1, where Noah is told to be fruitful and increase in number and fill the earth again. So these land bridges between the continents after the flood, which probably lasted for several hundred years, and I'll tell you why as we get through this as well, would allow in these centuries for animals and man to migrate all over the earth again and repopulate the earth just as God had commanded Noah to do. So if we see these land bridges will disappear later on. And again, looking at a map of the ocean floor, it'll become pretty obvious what's going on here. And now again, since all these great amounts of minerals and materials are brought up to the surface, these sedimentary layers form really quickly, like we talked about, in the matter of several months, forming our strata layers. In the process, there would have been huge amounts of animals and plants. I mean, there's literally billions of animal remains in the fossil record. We haven't found them all yet either. We've only scratched the surface of exploring the fossil grounds that we have in the earth. There's many places we've never looked. So chances are there's a lot more fossils out there than we even realize. So they're produced in massive numbers. One of the things you find worldwide too are what are called fossil graveyards. So these are graveyards that sometimes contain billions upon billions of fossil remains of totally different animals and plants that would have never lived together, all jumbled up together, as if they were put in a big blender. Like you'll find shark's teeth alongside horses. I mean, they didn't live in the same environment, right? So you'll find in these fossil graveyards disarticulated remains, which basically means that the bones are no longer together. You know, like if you disarticulate the bones of a dinosaur, it's not in the shape of a dinosaur anymore, but you'll have all these dinosaur bones. But they're all jumbled up as if they were put in some kind of big blender or mixer. And so, according to evolutionary theory, horses didn't evolve at the time that dinosaurs were around, for example. I mean, but we find things, fossils, that are completely out of place. Now, there's a process of liquefaction that would tend to sort certain types of animals and plants into certain layers based on their buoyancy, not based on how long ago this happened. So certain things would rise more or sink more depending on their body mass, their buoyancy. But there would be great amounts of anomalies to this, okay? Where if evolution were true, you would never find two things that were supposedly live millions of years apart from each other. You never find them together in the same strata layers, right? That doesn't make any sense. If one animal died out millions of years and multiple layers came up after that, another animal had evolved, you should never see them mixed, but we see this all the time. There's out of place fossils. There's also strata layers that are backwards from each other, that are not even in the right order, according to evolutionary theory. And we also see what are called cyclothems, which are repetitive strata sequences where you'll find certain materials that are in one particular sequence, and then above that, you'll find it repeated. You'll find another group of strata layers in exactly the same order that the lower one was. So something separated materials above and below, and because of that, what's below, because of liquefaction, would sort into the layers. What's above would be the same basic material. It would sort also into the same layers, but be separated by a boundary, and you'd see the same repeated cycle. And that makes absolutely zero sense when you talk about evolution. Okay, there'd be nothing that explains that. So we see this again. We talked about polystrate fossils as well, that they couldn't be vertical through multiple strata layers. And now we also see that coal and oil deposits will form from decaying plants, and they form quickly. In fact, we can experimentally produce coal and oil in a matter of months. If the conditions are correct, under the right pressure and the right heat, we can start producing coal rather rapidly. And it doesn't take the millions of years, again, that evolution will tell you. They'll tell you, oh, this takes millions upon millions of years for this to happen. Well, it doesn't. Okay. We also see salt, what are called salt domes. And we'll also see huge amounts of salt that would have been precipitated. Basically, salt is sodium and chlorine combined together, would have precipitated out from underneath the plates, and explains now why our oceans are salty, why there's so much salt in the oceans. And then we find as the rising floodwaters eventually rise enough on the Earth, the waters that would have been shooting up out of the openings between the plates would have been overcome by the waters, and so the torrential rains would stop. So imagine that you're looking at a swimming pool. Let's say you got an empty swimming pool that doesn't have any water in it, and you take a hose with a sprinkler down to the bottom of the swimming pool. You turn it on, and you got water jetting up, right? And it comes back, and a lot of it falls back down in the swimming pool. Well, as the swimming pool starts to fill up with water, it'll get to the point where the water is high enough where it overtakes the water coming out of the sprinkler, and it won't jet up anymore, right? You'll have enough water above it that it wouldn't be jetting up again. And that's what happens here, is that the floodwaters rise enough where it overcomes the jetting waters coming out between the plates, but the waters continue to rise even after that happens. And this is recorded in Genesis as well, in Genesis 7:24. So how does the waters continue to rise even after the torrential rains stop? Well, this explains that, because we have water still oozing out from underneath the plates for a while, causing the waters to still rise even after the end of the 40 days and 40 nights. And I know we're out of time. I heard the bell.